Um, Hello. Uh, I was recording earlier, but I ran out of memory, so I'm gonna try it this way. So, I decided to do my forecast on sh eggshell production in the U.S. This was something I had done before a few years ago, and I was interested in trying it again, mainly because um, I happened to be applying for a job, and the guy saw my forecast and he recommended me to go to this program. So it was something I wanted to try again, see if I could beat my last attempt. So there's this whole big industry around forecasting egg production in the US and really globally. Um, there's the entire field of study of agricultural economics. There's the Farm Bureau, I believe. I have some friends that work for. And so there's a lot of people that have done this before. And so I could find some great papers on people that have attempted this and kind of learn from their mistakes. I kind of had like a pre-made little framework of what I should be doing. So some people will use like a linear regression on egg production data in the US and try to figure out what's driving it. But as we all know, linear regressions generally don't explain that much of the data. In this case, around like 37% of the data is explained by linear regression. And some other researchers I found decided to go ahead and use neural networks. Um, Neural networks, they can work great, except they're more expensive to build. They take longer to train. There's all kinds of drawbacks on that. And so a REMA model is kind of the go-to. A REMA model, it can take care of things like non-stationarity. It has trouble with kind of like the stochastic parts of a data set like this. It goes up and down, and a REMA model isn't great at like figuring out like stuff like variance and variance, but overall it does pretty well. So I'll go right into my methods. So I took data from 2017 to 2022 off the USDA website. You can filter down for whatever you want. You could have looked at like egg storage or eggs used in restaurants or all of that. I try to keep it simple because I haven't done this before and just look at the monthly total egg production in the US. So we're not including like imports or exports. We're just looking at survey data of farmers and basically what the farmers reported to the government that they harvested, basically. So we wanted to find out kind of what kind of model would be great for this. I started off by just doing kind of like an ACF plot. So I knew from working with this previously that this data was not stationary. I did an ACF plot, and down here, see if I can mark it. Down here, we saw that this ACF plot shows us that it's not stationary. These bars are going up and down like that, and on a stationary time series, it'll be kind of a slight decline. I'll just move on. To take care of the non-stationarity, you did a Box-Cox transformation, and that does the differencing for you, and so you can feed it into your models from there. Next, to get to the results, we had these 5 models. We had the ensemble model, we had the ARIMA model, a couple different kinds of ARIMA model, and we had a drift model. I decided to use BIC, the Bayesian Information Criterion. I've just been when I was reading those papers, I was finding that that's kind of standard. It's a nice balance between like not having information loss on more complex models and also model accuracy. Another interesting point, you can see the trend line down here. So during COVID, there was trillions of dollars in stimulus, and that caused like real increases in production. And then we have kind of like the Fed increasing interest rates, and that, you know, slows down the economy, and you'll see the egg production return back to normal. And then try to quickly talk about things I wish I did differently. So things I wish I did differently, you know, I wish I looked more at like variance and variance. I wish I looked more at like stochastic elements, and like try to apply that to my ARIMA model. Something else that would have been great to do was try to incorporate price. So a lot of the other models I looked at when I was reading about this were people would take price and production and then try to run ARIMA models on both and figure out what drives what and come up with a more accurate forecast, because that's also true. Like depending on the price, producers are going to decide like, do I want to produce more eggs or do I want to like hold back? Things like that. Decide how to spend their capital. And overall, it looked like my ensemble model worked best with around like a 1400 BIC, which was the lowest of all of mine. Thanks.